So I know this next panel will be insightful, and I'd like to introduce Ivan Tarapov, our panel moderator for the medical applications and XR panel. Ivan is a principal group manager in the healthcare AI group at Microsoft's Healthcare and Life Sciences, where he works on novel techniques for the development of healthcare AI solutions. In the past, Ivan had worked at Microsoft Research, where he contributed to the development of state-of-the-art AI systems for automatic segmentation of CT and MRI scans, and created a module on 3D medical imaging for Udacity's AI for Healthcare online nano degree. Please help me welcome Ivan.
Hello, everybody. So I'll be moderating the panel, and at this point I would like to invite our esteemed panelists, and we'll take our seats there and get started. So hello and welcome. Looks like this is the next to last event of the day. I hope you're still energized and are eager to hear about what AR has to offer to the field of healthcare and medicine. So I'd like to have our panelists introduce themselves and just say a few words about what you're passionate about and how are you using AR in your work. So Mark, why don't we start with you?
Okay, sure, thanks. And thanks everyone for being here, and thanks to the UW and STMicro for organizing. It's been a great event. I'm going to leave with a lot of thoughts to write down when I get home. So I work for a company called Surgical Science. Some of you in the room might know us as Mimik Technologies. Mimik was a company that was actually founded out of technology from the UW. Our founder and CEO is a graduate of the HIT Lab. And he developed a simulator, a VR simulator for training robotic surgeons. And so we've used that to train thousands of surgeons for the Da Vinci robotic system, and now we use it for other surgical robots coming to market very soon as well. We were acquired earlier this year by Surgical Science, hence the name change. Surgical Science, another simulation company. They do other types of surgery, but I'm going to speak mostly about my experience with robotic surgical VR training. I'm also a graduate of the UW, graduated here almost 20 years ago now with a master's in mechanical engineering, even though my thesis was through the bioengineering department. And so I've worked in various medical device designs before coming to Mimik Simulation to help build our next generation of robotic surgical simulators.
Thank you, Mark. Yep. And next up we have Sophie Stellmach.
Hello, everybody. It's a little hard to see you, but so yeah, my name is Sophie. I'm an interaction design lead at Microsoft, working on the HoloLens team, and so I'm not entirely sure how I landed on the medical panel because my background isn't medical, but I did work with one of our partners for HoloLens 2 in 2019, which was Philips Medical Solutions, where we essentially worked with that partner around how we can support surgeons in the ER to use HoloLens in these settings where their hands are busy. And so one of the things there was to, for example, use one of our sensors, which is eye tracking, to then interact with holographic content there. And so I can talk more about it later. I don't want to take too much time, but so that would be one of the kind of also coming back to the human-centered design, really working very closely with our customers there to find out how we can design these systems to tailor them better to these specific user needs, right? And so in this case, again, as I mentioned, eye tracking was one part. There's also around voice input, how can we leverage that better? And then, of course, also our fully articulated hand tracking, where you can just like reach out, poke buttons, holographic buttons, which was also part of that application. But again, I can talk about it more later. I want to leave enough time for everybody else.
Thank you, Sophie. Glad to have you here. Martine, why don't you introduce yourself?
Yeah, hi everyone. My name is Martine Stillman, and I am the Vice President of Engineering at Synapse Product Development. I've been with Synapse for 17 years here in Seattle. We have an office in downtown. Synapse is a product development firm, and we have worked on many different VR and AR projects over the years. We have a particular specialty in tracked objects, so items that we develop for companies who need to make an object that they can use in a VR space. My favorite is NASA. Hired us to do a tracked object that they could use for training astronauts to use something called the PGT, the pistol grip tool. So we certainly have a good background in that, and I'm very interested in how we can use user-centered design to improve medical outcomes.
Thanks, Martine. And Hunter, please.
Hey, I'm Hunter Hoffman. I'm from the Human Interface Technology Lab, what Tom Furness started, the first speaker this morning. And I'm now in mechanical engineering at the Human Photonics Lab, which is kind of a descendant of the HIT Lab. And my specialty is immersive virtual reality, pain control, where I've worked with Dave Patterson at Harborview Burn Center and also at Shriners Hospital for Children in Galveston, Texas, using VR to distract children and adults during painful medical procedures. And I also have used VR for some of the early research on exposure therapy for phobia and post-traumatic stress disorder from September 11th attacks.
Thank you, Hunter. And with that, I would like to open up with a question. So actually, a couple of days ago, I had a minor surgical procedure done on me, and it was no surgery, and they did it with an endoscope, and it got me thinking that actually in the endoscope they changed how surgery is done, right? Because now you can see what's happening inside, and you can do minimally invasive things. They've advanced a lot. That made me look up when endoscopy was invented, and actually the first endoscope apparently was invented almost 200 years ago, right, in 1806. And that got me thinking, what is the promise of XR that we're seeing right now rapidly evolving to the physicians and patients, right? So how will XR augment how procedures are done and how healthcare is delivered? I'd like to hear your thoughts about that. So I don't know, Martine, maybe we can start with you. What do you think?
Yeah, absolutely. I actually would like to talk a little bit about, not necessarily in the surgical area, but how I think that healthcare in general could be really benefited by XR, AR, VR, all the different kinds of augmented reality. I think that, it's really interesting to imagine a world where you could actually have, from birth to death, healthcare without going farther than 300 yards from your home. What would that look like? Is that possible? And I think the answer is there's a lot more that could be done without needing to visit a hospital, without needing to go to a doctor's office. And I think if we can be thoughtful and proactive about how we can use sensors in people's daily lives to get a better data set that then physicians and specialists could use, we could actually look forward to a more inclusive, less invasive, and frankly, more accessible healthcare future for all. So I'm really excited and interested to see what the future will bring on these topics.
Yeah, absolutely. The promise for telemedicine is huge. Any other panelists want to add to that? How do you guys think XR will change the healthcare delivery?
Yeah, maybe just to follow up on the not leaving the home or just moving 300 yards from the home. For me, it's also about democratizing medical help, right? Even when you think about certain field doctors, just having all these options, then even if they're out in the field anywhere, that is actually for me something that is super powerful.
I'll jump in. So, Mimik Surgical Science approaches healthcare primarily as a training company, right? We train surgeons using VR, XR technologies. So that's been my experience. XR, VR, AR, these are technologies that basically allow people who wouldn't otherwise have access to surgical robots to train on them. We can see earlier and earlier in a person's medical training, they can now jump on a simulator and start seeing what is robotic surgery, and maybe that drives their interest. It used to be you could only train on a robot. You had to get into the OR. You had to find time to have a training session. Hospitals don't really like that. They want their robots used for surgery, not for training. That's how they make their money. So for residents, getting time on a robot to actually learn was very challenging, and it's even more challenging now. There's new rules and regulations about how much time they're allowed to spend outside of their other residency obligations. So VR, XR, these commercially available systems now are just making access to surgical training more accessible, and I think it's only going to come down. We're going to start seeing these in medical schools and high schools even. STEM programs are going to start seeing XR, VR applications for surgery.
That's great. Hunter, what are you looking forward to? What do you think are...
So when I first started using VR for pain control, we were using a computer this tall, and then that was early, like in the early 90s, and now fast forward. So you see this decentralization is really, I think, a huge consequence of this Oculus revolution, where now what we do is instead of everybody having to come to the hospital, the VR systems are so cheap, you can send people home with them, and then they can do a lot of their like for chronic pain, they can learn coping skills and practice and do physical therapy. And I think the sensors is a really important element of healthcare. Increased access to information about the patient's mental state, physical state, hormones, all different kinds of information. You're going to have a much more clear. You're going to have a lot more information to evaluate how a patient, whether they're getting worse, if they. I think the sensors combined with the helmets. Another example I just saw when I looked into it a little bit was, with the augmented reality glasses, you have the cameras, and there was one example where the women were breastfeeding, and the early Google Glass, the doctors could see from the mother's perspective, how they're holding the baby, and so that gives the therapist kind of the patient's perspective. I think the drop in price is really exciting, and it's decentralizing, very similar to what happened when you used to have the vacuum tubes and everybody had to go to get their programs done at a central location, and then when the PCs came out, everybody got their own computer, and now it's the same thing with the VR. It used to be you had to go to Harborview because it was a $90,000 system. I mean, I'm using two helmets. One helmet is $35,600, and the other one is $300, and the $300 one is as good or better than the $35,000 one. So it's jaw-dropping how much it's improved just since 2016.
That's great. And I think it's interesting how with the evolution of VR, XR technologies, there is an evolution of how we approach software and how we approach the questions of designing software, designing user interfaces. So Sophie, I would like to ask you this question. A lot of your work has to do with user-centered, like human-centered design. So can you tell us what do people understand when they by user-centered design, and how that could be applied to the field of medicine in your opinion?
Yeah, that's a good question. Whether it's user-centered design or human-centered design, essentially it's really about not just making assumption on what the user might want, the customer might want, but actually talking to them early on, right? It's kind of like the lean startup design also, where it's like talk to your customers early. And so in this case, talk to your users early and really find out what are their needs and how can you really cater to these needs. And so one of the things, from HoloLens 2, of course, also, is that it's targeting more businesses, right? And like first-line workers and even like surgeons. And so how can we work with these type of users then to really make sure that we're not designing just with kind of like what we think surgeons might need, but actually talking to them, getting feedback, iterating on that feedback, and then further and further improving the designs, right? I did want to actually follow up on some of the things around the sensors also that came up, because it's just so exciting for me. So my background is also in eye tracking, and when I first started with eye tracking in like 2008 or whatever, an eye tracker would be easily $40,000, $50,000, and now it's just included in a HoloLens 2, which is mind-blowing to me, and it can actually also be used to detect certain mental conditions. It can be used to, for example, there are certain applications to detect if a user has a concussion or early onset of Alzheimer. And so it's really exciting to think through when we talk about XR and extended realities, right? How can not just the sensors in the glasses, but how can we combine these, fuse these, even like with a Fitbit on your arm, right? How can we then create this more complex picture of the user and the kind of ongoing sensor input, like for example with Fitbit, over time, of course, you know, oh, you haven't been sleeping well for the last week. So how does that affect your health, right? Yeah, I was diverging. Sorry.
No, that's great. Thanks. Anybody has to add anything? Martine, maybe you have some thoughts about what user-centered design might mean for.
Yeah, actually, I was just reflecting on a similar application that Sophie was mentioning. So Synapse did a product called the Ava, which was a wrist-worn sensor, a wrist-worn biometric device designed to help you understand your fertility. So for women who were trying to get pregnant, it was a way for them to take a really complete biometric data set while they slept. So you put it on at night, you go to sleep, and then in the morning it tells you a lot about your basal temperature and your heart rate. Actually, your resting heart rate correlates to that. So you can tell a lot about your fertility from just those two metrics alone. And I think the data in part of AR is really interesting, right? So there's a lot we can learn and use, you know, in an AR perspective. But if there's not good data coming into the system through sensors that are, you know, accurate, then there's not a lot to, you know, display in an AR system. And so I think it's a whole ecosystem that needs to be considered, right? And which pieces of this ecosystem do users really need? And you know, in this particular case, the Ava, it actually could probably in the future be replaced by your Fitbit as long as, you know, your Fitbit got sophisticated enough. So I think it's interesting to consider these evolutions in this sort of ecosystem perspective and what will happen in the future. Could you do all of the same functionality? Could you tell so much about your health through your Apple Watch, and that could be sensory, you know, data inputs to your physician.
That's great. Martine, I would like to follow up. So you mentioned, like when we were chatting before the panel, that you think about sustainability goals a lot, like when in your work. So how do you think, like AR and medicine, how does that integrate with sustainability goals that Sylvia might?
Yeah, well, first of all, one of the primary considerations about sustainability is really about efficiency. And so I think that that is a huge thing to consider, you know, how AR can really benefit and augment. You know, Mark was talking a little bit about, you know, getting surgeons to practice without having to be in an operating theater, right? An operating theater takes a lot of manpower to run, a lot of electricity, a lot of people's time, a lot of money, a lot of resources to have that facility up and running. Whereas if a surgeon is practicing, you know, wearing a headset at their dinner table, that's a much more resource efficient way to get those practice hours in, right? So I think there's actually a whole sustainability piece here that's just about using the right thing for what you're trying to do. If you're not trying to do surgery, don't tie up a whole operating theater just for that. I think another thing about sustainability is trying to make sure that you're doing the most efficient thing with what you have available. And to the point of, the Ava or the Fitbit, do you need 7 devices to take the same biometric data set? No, you don't need that. So the most efficient way to do that would be to have one really sophisticated and high quality device that could take all of the data that you need, and then make sure that you were having that data available in a way that's accessible to different practitioners who might need to use it. So could you take the same data from your Fitbit and make sure that your different physicians could have it? So I think that would be the most sustainable way to do that. And lastly, I wanted to say that, making things that are quality, that are upgradable, is really key to making sure that they're future-proofed and not just trash. And so I think that's another thing to consider. In some of these applications, it's better to actually make something great that could then get a simple software update 6 months from now, rather than, you need a whole new piece of hardware every 6 months or 9 months to replicate.
Yeah, absolutely. Mark, I would like to ask you, so really blending AR, VR and surgery and robotic surgery, that's really pushing the boundaries of the possible, right? That's something that people haven't even dreamt about 20 years ago maybe. Where is this going? Are we going to see doctors operating from the comfort of their living rooms, or fully autonomous surgeons? So what is the future?
Well, I don't want to be the first patient where my doctor's in the living room. Yeah, 20 years ago, robotic surgery didn't exist, right? It's pretty new technology. But interestingly enough, the first surgical robot, it was developed through some collaboration with the Army, and the goal was to have a surgeon be remote and be able to operate on a soldier on the battlefield, for example, and the surgeon would be in a safe environment. So that was how the Da Vinci robot, the precursor to the Da Vinci robot anyway, got started. That was 20 years ago. Through obvious challenges in technology, safety, security. That's not the way it's done today, but it certainly could be. I mean, the technology is getting there. We have the network bandwidth right now. We have the the ability to see into the OR from outside of the OR. And to see parts of the patient, maybe that you can maybe even see into the patient even better, rather than being on top of the patient. If you're in a room where you can look into to monitors that have all kinds of patient data streaming at you. I don't know when we're going to be seeing that kind of remote teleoperation. There's certainly teleproctoring that occurs today. A surgeon who's struggling on a case can call up a friend, and they can draw on a screen, and the surgeon sees it on his screen. You are going to start to see, probably in the near future, some of the aspects of surgery, not all of them. You still need the surgeon for the key decision making, but you'll start to see some simple automation of tasks as well. With surgical robots now, you have the capability of automating things like needle throws, suturing, for example. And then couple that with a lot of the work that I'm sure you're involved in AI, we can easily imagine augmenting what the surgeon sees with overlays, no-fly zones. We saw it in cars, right? First you had your backup camera, then you had your lane change warnings, and we're going to see this for sure in surgery in the very near future. And then of course that does lead into the automation and the self-driving car discussion as well. So yeah, really the sky's the limit when you start coupling AR with robotics and other technologies that are gonna appear. Yeah, I think the sky's the limit. I think a lot of the people in the audience here are going to be developing those technologies for us.
For sure. Yeah. I'd like to shift gears a little bit. So, Hunter, you've done a lot of fascinating work around the psychology of people using VR and how it changes their perception of things. Can you talk about that a little bit? First, talk about the pain management work a little bit, and what is it about VR that makes people perceive things differently than when using other media?
VR has an immediate effect on patients So for example, we took a borderline personality disorder patient, which is a very severe psychological problem. Marsha Linehan, who's here at the University of Washington, and I and some other people collaborated on using VR mindfulness. So, learning coping skills while you're in VR. And it was really, after 10 minutes in VR, these patients, their negative emotions dropped and their positive emotions jumped. So I think there's just you can help people to, you can train people to have more normal patterns of brain activity with the virtual reality. Just like you're training a surgeon, you can train a patient to have more healthy thought patterns. So you can train people when they start to have a meltdown to see the signs. And of course, this really, I think the most effective applications of virtual reality in mental health are ones that insert VR into existing effective treatments. So it's really, so a lot of treatments use imaginal exposure, and you can just insert virtual reality exposure. And in other words, you can use VR to enhance the effectiveness of what's already been empirically validated as an effective treatment.
Thanks. Any other thoughts from the panelists?
I do have an example. I was thinking, because a lot of my research is with immersive VR. One interesting augmented reality example is exposure therapy using augmented reality, where one of my colleagues in Spain had cockroaches running around the table that you could see. So you're in your kitchen or your own room, and then you get exposed to objects that elicit your fear, and then the therapist helps you learn how to become less and less upset when you. So then, when you see a real cockroach, you're like, okay, that's no good, but I can deal with it.
Fascinating. Sophie, I know you've done some fascinating work with Philips not so long ago on the HoloLens, right? I'd like to hear from you. What have you learned from that project about how physicians would like to interact with AR? What was new to you?
It was very interesting. As I mentioned, it was for HoloLens 2, one of our core interaction inputs is hand tracking, and so that didn't work. So we had to quickly learn, like, okay, we have to very much change gears there. And so one of the things that we were using was eye tracking, but the problem there was also, if you only can use your eyes to interact with the UI, that is also pretty limited, because then how would you do a selection? How would you, like, they had like different medical images where they wanted to zoom into a certain detail. How can you do that just using eye tracking? And so we were trying to use voice input, but of course the surgeons also have face masks on, so sometimes the voice input isn't well recognized. So just working really through all these kind of different obstacles to come up with the best solution was very interesting. It was before that, like 2017, 18, it was just, we were designing a lot just based on assumptions. But then when we were actually working with partners like Philips, it was just so much more gratifying, because we came up with solutions where we actually knew these are helpful solutions to these different scenarios. So that was, for me at least, very mind-opening. We did end up using a lot of eye tracking with dwell-based, where you kind of like have to stare, but then also used minimal hand interactions with it. So that was the final solution then there.
Thanks for sharing. I'd also like to hear. So there are a lot of ideas about where VR could be applied in medicine. But what things should the developers be wary of? Like, what are the potential pitfalls? So maybe Martine, maybe you'd have some ideas as a product development person.
Yeah, well, we have a lot of clients right now who are becoming increasingly aware of privacy. And there is, I think, a huge amount of concern there, especially with regards to, medicine. Even as telemedicine starts to take off, there's a lot of questions around how can you make this a private or secure engagement, and what are the privacy pieces that we need to be aware of, right? And I think we're all becoming, more aware of, is our location tracked? How is that used? How is our, online activity monitored? And so I think that's definitely something that people will want, that developers, like those in the room, are becoming increasingly aware of. And I think there's also obviously there's some real safety concerns that people are curious about, but we have a lot of clients coming to us right now saying, I can't put a camera in the home. It's just not private enough. There's too many privacy risks. People don't want that. They're starting to have a really adverse reaction to even, seeing that. And so we have these, home fitness clients come to us and they might say, we want to do this connected yoga system that tells people when they're doing it wrong, but no cameras, please, right? And so it becomes this really interesting dance where we need to figure out what are the possibilities that can enable really rich interactions while still, being safe.
Interesting. Any other thoughts on pitfalls and
Yeah, I've got a comment on that too, from a slightly different angle. The health and safety and risk aspects are very real, and we all need to consider those. But there's another one that is often overlooked, and we can run our simulation software on the surgeon console itself, right? So people can use the actual input device for the robot to be in a virtual environment and practice in a safe way. But as we mentioned earlier, that's not always accessible to the trainees. So we've developed lower fidelity simulators that now we can put in sim labs and put in other places where the residents and the trainees can come and practice. And then we can take that a step further and now talk about the accessibility of an Oculus Quest 2, for example. But every time you make these more accessible simulators, you run the risk and the reality that they're going to likely be lower fidelity than the actual robotic console itself, right? The robotic console itself is a almost $1 million piece of equipment. Oculus Quest 2 costs $300, and the touch controllers, they're great. You can practice a lot of things, but they are not the surgeon console. So the risk is training bad habits. You can now get into a simulation environment where you're doing things that you just can't do on the surgeon console. So that is absolutely something that should be a strong focus for a human-centered design and engineering course when you're talking about lower fidelity training platforms for a different real platform. How can you give the user cues or other input so that you're not training bad habits and you're teaching them to do something that they can take and will be valuable when they get to the actual console itself?
Thanks. That's a really interesting insight. So we have a few minutes remaining. I would like to open this up to questions from the audience. Maybe if anyone has anything they wanted to ask.
I could maybe talk to that a little bit. I'm not a medical record specialist, but I think it's a great question. And there's actually, I'm not aware of work that's being done to actually bring this data into the medical stream. I just see this data being collected, and I want it to be. I think it's a really untapped so far, future scenario where your doctor could, to Sophie's point about your Fitbit knows exactly how you're sleeping. Does your doctor? Probably not. And I think that would be a really interesting thing to connect. But like you say, there's a lot of risks there and things that, a lot of obstacles to be overcome for sure.
Yeah, that's a great question. And, that's very big fear, especially in the medical device industry, right, where you're interacting with patients. But that patient data is really valuable, especially coming from a company that does training programs. You want to make sure your training is working. If I put my surgeons that are training on our platform into the OR, are they better surgeons? Are they safer surgeons? So we need that data. We want that data, but it doesn't have to be tied to a patient, right? It can be anonymized. It can be made generic in some way so that you can see that, what is the complication rate? What is the rate of return? And so there are ways to overcome that through anonymization, but yes, you have to be careful not to tie it back to specific patients, and those requirements are getting harder and harder, right? The European privacy laws are really strict right now through GDPR, so that is something that we are always considering, and not only from the patient perspective, but also from the surgeon's perspective, from the trainees. Now we are seeing people sitting down on our simulators in Europe, and we want to collect their training data. We want to give them reports to show them how they're doing. But this is performance data. This is showing how good they are at a certain set of surgical training tasks. And that is considered private personal data. So we have to be really careful how we collect that data and how we use it, even though it's extremely valuable and we want it.
Yeah, perhaps I can add from my perspective, when it comes to integrating things into electronic health records, a lot of that is facilitated by adoption of standards, right? And I know that, like at Microsoft, I work alongside a team that has developed a lot of software to support FHIR standard, which is like an emerging standard for exchanging and storing health record information, right? And but when we talk about data that's coming off AR and VR devices, that potentially can be huge data sets, right, depending on what you're collecting. And yeah, there's definitely a challenge up ahead for what sort of standards do we need to capture that type of data and incorporate that. I think once those standards are out there, it may transform the industry the same way as FHIR, DICOM, HL7 has transformed them in the past. Any other questions from the audience?
I could just add one thing. I just wrote a paper about telehealth during COVID and the shift of therapists using telehealth. And so there is some encouraging developments where Johns Hopkins and the Veterans Affairs saw the COVID problem coming and started making a lot of anticipatory improvements to allow telemedicine to be billed, to bill your insurance, to increase the security of the systems. So there has been some definite improvements, even just since COVID, that's allowed a lot of healthcare that would have been impossible before the improvements. And it was really interesting to me that in January of 2020, Johns Hopkins and VA already saw a COVID disaster and started doing legal changes, legal changes. And so it's when people say, oh, who could have predicted this was going to happen? It's like, well, VA and Johns Hopkins predicted it.
Yeah, it's amazing how COVID really had us skip like 10 years of telemedicine adoption, right? And basically jump ahead. And with that, I'd like to hear from others. Like, what do you guys think? Like, how has COVID maybe changed your perception of where AR could be used in healthcare or in your work? Any thoughts from others?
Sure, I can give a couple of examples. We actually had a little bit of an uptick in our simulator sales during COVID because robotic surgery is considered elective surgery, and elective surgeries were canceled for several months, right? And it's also a very high-skilled profession. And skills degradation, it's been shown that skills degradation for robotic surgery happens in just a few days. And these are now surgeons that aren't getting into the operating room for months. So they're certainly losing their skills. They need ways to maintain their skills. And portable simulators that they can access were a solution for many of these surgeons. We had surgeons reaching out to us saying, hey, can I get one of your simulators? And they were setting it up on their dining room table and going through and practicing their suturing and knot tying, in their off time because they couldn't get into the OR. So that was, one advantage where VR simulation really helped. And we see it not just for, for COVID, but any time someone is outside of work for an extended period of time. We had another surgeon who had a baby. She was on maternity leave for a few weeks, and she sent us pictures of her, doing some simulation training on her simulator while her baby was taking a nap on her chest in a baby Bjorn. So it's opening up opportunities for people who can't get into their normal practice to maintain skills.
Fascinating. Well, I think with that, any closing thoughts? I think we have time for maybe a couple of remarks.
Thanks for having us, and thanks for everybody's attention. This has been
Yeah.
great.
Thank you.
Yeah, this is fun.
Thanks, everybody. Thanks, panelists. It's been a fascinating discussion.